Hello developers, let's start developing. Today we're gonna take on the day 8 of the Advent of Code 2023. It seems to be some kind of a simulation problem. And once more, if you like this type of content, if you like me solving some weird puzzles, don't forget to click on those buttons, the likes, subscribes and whatnots. And of course, as ever, don't hesitate to tell me what I'm doing wrong in the comments. So, what we have now, we have a relatively short description. We have a kind of weird input that we have an instruction list here, which just says right or left, and the nodes are all connected with only two other nodes. So we have a right and a left node that we're connecting with, and we need to basically loop the input as many times we need to until we get to the from AAA to ZZZ. So it says right then left. So we're taking CCC and then we're going left on the CCC, we're going to ZZZ and we're getting there. It doesn't mean that it will always be just one run or that it won't be in the middle of the run. So we have left, left, right, left, left, right. Of course, here it doesn't really matter, but once we get to this, then we go left, left, right, and we're getting to the Z. How many steps are required to reach Z? Let's see the input. So we are supposed to have an AAA that connects to SQV and VLV and so on. And we have ZZZ. We're supposed to have ZZZ. Yeah, here it is ZZZ, which is connected to VLV. Which means that given this thing, we can go from AA to VLV, then to ZZZ. But no, that's not the way that we're gonna go. We're gonna execute this whole sequence of else and R's, and I think we might execute them more than once. So anyway, we have two examples that we can use to actually develop our thing. So let's take the demo input and then let's try to parse it. So what will we do about parsing it? Yeah, we have the lines. And once we have the lines, we can take the first line. That's the directions. That's lines of 0 actually. And we can say lines.slice. Start from the second one, so that means skip 2. And then we have this format, which is kind of a nice format for a regex. So, let's do it the other way around. So we have something that's from uppercase A to uppercase Z, and we have that 3 times exactly. Oh, and that matches, and then we have a space, an equal, a space, a parenthesis, and against A to Z exactly 3 times, and this thing once more, and then we end it. And why isn't it matching right now? Oh, this is a literal parenthesis, so we need to escape it with the other escape symbol, and then the last one is an unmatched parenthesis, and we also need to escape, and now we got our things, and now we actually need to add the actual groups that we want. So we want AAA, we want this, and we want this. So we should get AAA, BBB, CCC, and so on and so forth. And this is our matching regex. Okay, back to the code. So we're gonna need to loop through this line. Actually, we can use a map. For each line, we're gonna, we can use splits and whatnot, but I kind of prefer when I'm parsing text to use regexes as they somewhat explain the format. So we can say line.match this. We don't need the G's, don't forget, we already messed up on the G's once more, so it's supposed to be like this, so this is the match. And of course, if we don't have a match, something went horribly wrong, so we're just gonna throw. Otherwise, we have, yeah, we can use this, and it's not instruction IB, so it's source, it's left and right. So we will need to actually return. Since we're not doing, for now, we're not doing anything with a reverse way of doing. Yeah, I will. Let's return the source, the left and the right like this. And now I will say give it a reduce once over. So we have an accumulator, and we're gonna start the accumulator as an empty object. And in each loop, we're gonna say something like this, that the accumulator will have left, that is node left, and right, that is node right. So we will have it into a record, not as a, sorry, not as an array, because looping through a record is much faster, and this is a record when the key is a string and the object is a left and a right. This is a map of nodes, and then we will actually return our protest input, which is going to be interface desert, because we're going through a desert. We have directions, which is a string, and we have our nodes, which is a record of a source string, which is the node name, and a node. And the node will have this. So now we can just say return an object that has the direction and the node map as nodes as a desert, and that should be it. Just one more thing. We need to explain to our system that we're actually using a desert as an input. Everything is okay except this, the dummy code that I'm using in part 1 and part 2. But here I can just say return -1 and log the input. Let's see if we get our desert. npm start 8. Seems that this thing is parsed correctly, and now we just need to run it one by one. So we can say I can immediately deconstruct this into directions and nodes. I have a feeling that you need this thing, a direction index that will initially be set as 0. I will need a step count, which is also at 0, and yes, I need the current node, which is AAA, and I will need a target node, which is ZZZ. So now, while the current node is not the target node, we're gonna need to loop through the directions. Current direction is directions of dir index. Yes, that's the current node. It's nodes of current node. This has a left and a thing. And if the direction is left, then we're going that way. And if the direction is right, then we're going that way. Increase the step count, increase the dir index, and I will add a simple says that if the directions dir index is now at the end of the directions, bring it back to the end. So you can see that Copilot actually did an amazing job about this once I defined all the things that we're gonna need to do in the looping. So now we just need to return the step count. And if we're lucky in this time, the result will be 2, because we need 2 steps. That's great. And if all this looping and whatever thing we did is okay, then this is the real test. Oh, I need one more parenthesis. This should return 6. If this returns 6, this is a much better signal. It says 6. So let's try it on the huge input. And I have no idea how convoluted this example is. And that's one of the things with advent of code, that oftentimes you have no idea how long this will take or how it will do. I will need to do some analysis on the input for that. And who has time for that? So it says that it took me 13,000 steps to actually get to Z, which is a lot more than 2. But let's see if this is the correct answer regarding this left or right instruction. Yes, we are correct. Solve this one relatively fast. But, and now we have the more complicated reading part. You're barely left with significantly more steps to escape. Okay, that means that we might need to do some calculation, or that this thing will spend several years processing it. What if the map is for ghosts? Boo. Curious fact. With names ending with A, it's equal to the number ending in Z. If you were a ghost, just start at every node that ends with A and follow all of the paths at the same time until they all simultaneously end up at nodes that end with Z. Wow! Now we need to do parallel simulations. 11A and 22A. Use this instruction to simultaneously navigate away from both nodes you're currently on. Repeat this process until all of the nodes you're currently on end with Z. You choose, so the instruction is left, right. You choose all of the left paths. You choose all of the right paths. You choose all of the left paths, all of the right paths. So we're getting to 11Z but 22C. 22Z but 11B. And we just have a node that's neither A and B, and this is some kind of a terminator that we don't do that. So it seems now the problem with this input, this is an example, is that, come on, why doesn't the last parenthesis last me? Is that we're not gonna parse over the A's and the B's, so, but we don't have any other things, so I'm just gonna do a search and replace A with W all over the place, and that means that we have some 2's that we need to replace, and those are Y's. So this will parse, and this is the exact same example that we used before. And we need to get a list of the starting nodes. So for the second part, we basically need this, but we need to run it considerably longer. Again, directions, nodes. And let's take a look in our big input. Let's see how many cases we have. We have A equals something. How many starting nodes do we have? 1, GSA, DLA, MLA, MQA, AAA, JGA, 1. Seems that we have 6 of them, which should mean that we have 6 of these. Yes, ZZZ. And we need to get at them. So we have a 6 time harder problem. So instead of getting the current nodes, we need to get all the current nodes. So we're going to take the nodes, and then we need to, since this is an object, we will need to get object dot keys of nodes. Something like this, but it actually needs to be ends with AAA. So those are the current nodes. And now I will log the current node, and we don't have the, and we actually don't have a set of target nodes. It doesn't mean that we can end on whichever Z node we want. So it's not a one target node, which means that for 6 things, we have 6 factorial actually possible ending combination. It doesn't matter that the one starting on AAA ends on ZZZ, it can end on PXZ as well. So we need actually a check whether the current node has reached the target destination. So we're gonna have is target reached, and we're gonna need some current node, which is a string array. And the check will be current nodes. Every current node needs to end with Z. A single Z, not 3 Z's. So while the target is not reached, and this is not the current node D, it's current node S, plural. And we're gonna need to do this inside of a loop. So we're gonna need to say for each node of current nodes, we're gonna need to do this, execute a step. So the current direction is the directions of dir index, that stays the same. The current node data is nodes of node. If the current direction is left, and we have the next nodes, and after we do that, we just swap out the current nodes. And we need a type on this. It's a string array. So if the current direction is left, then our next nodes includes this thing. Push the left one, otherwise push the right one. And we're replacing what the current nodes mean. We're increasing the step, we're increasing the dir index, and we're returning the step count. Let's see. So the first part was, did I put it on the huge input? Yep. Where does the first... Oh, we don't have an AAA for the first thing. And we don't have a ZZZ. Well, this sucks because now I cannot run this as I want it to be run. Yeah, we don't need the target node because we have the function that says that. So I will have to replace this with a return -1. So we're not running the part 1 while we're running the part 2 because the demo inputs are sufficiently different. So this detected that we have two starting inputs and that this thing finished in 6 runs. Well, going back to the huge input and well, let's try it. Maybe it will finish in some same time. I have a feeling that it won't, but who knows? So we'll let it run for a few minutes and so, or something like that. Actually, I will stop it right here because a lot of the times a program can just go off the rails and do nothing, but we want to kind of detect that. So I will just add a code that says if the step count is modulo 100,000 is 0, then log the step count and see if this is too much debugging info or not. It's apparently not. So let's say we ramp it down to 1,000. And log the current nodes. Oh, we didn't want to do with part 1 because part 1 never reached those numbers. So I have a feeling that this is a better number. Yeah, and not good enough. So I will ramp it up to something like 2 million. So in each 2 million runs, it will just display where it is at now. And if that thing's changing and so on, it means that it's doing something. Yes, so for each 2 million display, and I see that all of them are changes, so everybody is moving around. And since it set significantly longer, I will let this run for a few minutes. Well, it's gotten up to 1 billion and it shows no signs of slowing down. So that means that so even if the answer is something like 7 billion, so the answer is not going to be in the thousands or something like that. It's going to be in the billions at the very least. And I have a feeling that if I was designing this and if I made it that the answer is in the billion, it's going to be in the trillions or even more. Something with 15 or 16 digits. Note that most languages are quite correct with integer calculations up to around this 14 to 16 digits. So that is where most of the big numbers in AOC lie, which means that we're going to need to take an alternative approach. So we can do that. I have an idea of what we might want to do. So we're gonna need to do some kind of analysis of this thing. Maybe since the input actually has, well, it's not short, but it's not long. It's 293. We can do an analysis of the each of the sources. So maybe we have a situation, not maybe, definitely we have a situation when we get into a loop in 1 billion items, we're going to get into a loop. So that means that we get to the same point where we were before after a certain run of events. And I'm going to use the start for that. So if there is a loop, hopefully they don't have something that's called a lead into the loop, then we would have to basically remember all of the places we've been. But they shouldn't be perverted like that. So we're gonna need to find a loop of a certain size around each elements. So I will just analyze how long does it take to get from each source to a z. And then again, how long does it take to get to the same z. So we will see if maybe we can run analysis. Because if we have two paths, because the problem is that we need to arrive at the same time. So if we have one thing that arrives every 7th iteration, so for example, and we have another thing that arrives every 11th iteration, then together they will arrive at the 77th iteration. So, for example, if we have, yeah, we're going to need to do some primes for this. So if we have one that arrives every 7th and every 11th and every 13th, and every 17th and every 19th iteration and every 23rd, then basically the solution will be something like this. Of all of these, so it's gonna be this number. So you see that we have relatively small input numbers, and here we are getting, well, basically 1 million. So if this is not 7 but 7 times 8, let's say 56, we have a huge number. And if this is actually, I don't know, which is another large number, 11 times 97, something like this, and we're getting this number. So it's quite easy for the guy that is designing the task to make sure that the input isn't feasibly large. So unless we gotten really, really lucky and got an answer up to 1 billion.8, we're not gonna get an answer anytime soon. So part one is done, and for part two, we will have a separate video where we do the input analysis. Keep developing and see you in part two, which eventually should be somewhere over there on the screen. Yeah, yeah, you'll find it.